Hi, everybody, and welcome. My name's Victoria, and I'm an educator here at Lowell Observatory. And today I'm going to take you on a tour of our historic Pluto telescope, as well as our Giovale Open Deck Observatory. So one of our most historic telescopes, as well as some of our new telescope facilities that we use for public viewing in normal times. So right now I am at the Pluto Discovery Telescope, or the Abbott Lawrence Lowell Telescope. This telescope was built back in the late 1920s to discover Pluto, though it wasn't called Pluto originally, or at first. But the story of how Pluto was discovered really starts back in the 1700s. In 1781, an astronomer named William Herschel made the first discovery of another planet. This is because we can see all the planets through Saturn with our naked eye in the night sky. So no one ever needed a telescope to find these other planets. They always knew they existed. But in 1781, William Herschel discovered the planet Uranus, which is far enough away from the sun that it's too dim for us to see with the unaided human eye. So with the discovery of Uranus, Uranus really threw a wrench in our solar system, because it didn't quite obey Newton's laws of gravity and Kepler's laws of planetary motion. Those sets of laws tell us how the planets should be orbiting around the sun. And unfortunately, Uranus was speeding up in parts of its orbit where it shouldn't have. So it was disobeying the laws. And this puzzled astronomers for quite a long time before they realized that maybe if we didn't see one planet, we didn't see two. So astronomers set out searching for another planet. But this time they didn't just have to blindly search and stumble upon it like we did with Uranus. Instead, astronomers used math. They used math to predict, based on Uranus's orbit, where this other theoretical planet should be. So they predicted it using math. One mathematician named Urbain Le Verrier, he predicted where Neptune would be less than a degree off in the night sky, which is incredibly close. The full moon is about half a degree. So we found Neptune in the mid 1800s, and Neptune was supposed to fix the solar system. So it was supposed to make it that everything could work once and everything would. The problem was, originally we didn't get the right mass for Neptune, so we thought it was a little bit smaller than it actually ended up being. This threw everything off once again, and it looked like there was something else missing in the solar system. So astronomers such as Percival Lowell decided to search for this planet X once again. They called it Planet X, like find the missing X, like in math equations. But Percival Lowell died in 1916, not having found his elusive Planet X. So in the late 1920s, his brother, Abbott Lawrence Lowell, donated the money for us to restart the search for Planet X. And with this, we were able to purchase a new telescope, which is the one you are currently looking at. This telescope cost about $10,000 back then. So it was quite expensive. But this telescope is specifically designed to search for another planet, especially a planet that's very far away. One of the advantages of this telescope is it has a relatively small aperture, so it has a very wide field of view. This telescope will look at the same area of the night sky about the size of your fist held out at arm's length, which is quite a large area of the night sky for a telescope to look at. The other advantage is actually back here. It's built to take pictures. So back in the late 1920s, that was done by using photographic plates. These were large glass plates coated in a chemical called silver nitrate that, when exposed to light, it undergoes a chemical reaction and takes a picture. So who was doing all of this? Well, most of the burden of searching for Planet X fell upon a young man named Clyde Tombaugh, whose picture you can see over there in the corner. In fact, I can zoom in on it a little bit. This is Clyde Tombaugh. He got his start by building his own telescopes in his backyard. He got to start building his own telescopes in his backyard, and then he drew planets like Jupiter and Mars and sent those drawings here to Lowell Observatory. He was looking for feedback on his drawings from real live astronomers, and he sure got some. In fact, our director, Vesto Slifer, was so impressed with the level of detail that the young astronomer had managed to capture that he offered him a job here at Lowell Observatory as an astronomer's assistant. And Clyde Tombaugh made his way from Kansas to Flagstaff, and at first he was doing a lot of odd jobs. He was shoveling snow off the telescope domes, getting mail from downtown Flagstaff and distributing it, doing grounds work, that kind of thing. But then once this telescope was completed, his job was to take exposures. These were hour-long exposures typically, though some went a little longer. So these were hour-long exposures of the night sky along an area of the night sky called the ecliptic. This is the area of the night sky where all the planets pass through, because our solar system is kind of like a big disk. So everything kind of follows the same line through our night sky. And he knew that if there was another planet out there, it would likely be along that same line. So that's where he thought to search. So he would take these pictures, but he wouldn't just take one picture. You can't discover a planet by taking only one picture. In fact, you need two. Because the planets are so much closer to us than any distant star we can see in the night sky, they move. Just like when you're driving down the highway and you see a big mountain in the distance, the mountain stays still. In this analogy, the mountain is like the stars. The stars stay still and they don't move very much. They take thousands and thousands of years to move. So, if you see something like a wildflower on the side of the road, it zips right past you because it's so much closer. That's what the planets do. So you can actually see the planets moving throughout the night sky just because they're closer to us than distant stars. So what Clyde Tombaugh would do is he would take an image of a set of stars in the night sky using these two spotting scopes to find those stars. He would center up one particular star in this eyepiece here, and then follow it for the whole hour, making sure he didn't get any star trails in his picture. And then Clyde Tombaugh would go back about a week later and find that same set of stars again. Those same two, or he would pick out two bright stars and make sure he found those two again. Then he would take a similar exposure. So we would try to take one that was pretty similar. And then came the fun part. It's the world's worst game of spot the difference, because on each of those pictures, there were anywhere from 100 to 300,000 stars. And of those stars, he was looking for one tiny dot that moved. One tiny dot that jumped a couple of millimeters across his image. This would be a planet. Anything that moved would have to be something inside of our solar system, so something like an asteroid or perhaps a distant planet. So Clyde Tombaugh set about searching, and after about 9 months of searching with the telescope and comparing those images in a machine called a blink comparator, he finally found what he was looking for. He found one tiny dot about the size of a pinprick that jumped a couple of millimeters over 6 days from January 23rd to January 29th, 1930. He made that discovery on February 18th, 1930. And that is the short story of how Pluto was discovered. It was discovered here in this telescope and as well down in our Slifer building here at the Lowell Observatory campus. The dome itself was built, the gorgeous dome was built by our local dome craftsman, Stanley Sykes, and his brother, whose name I forget. But Stanley Sykes mainly designed the dome. And it has those shutters there that open out to the night sky. And then the whole dome turns around by a big motor that is actually out for repair right now. Some electrical storms here in Flagstaff caused some damage to the motor, but we are getting it repaired. So that is how the dome works. It rolls on these railroad car wheels. That is what the Clark telescope also used to roll on, but until we changed it to car tires. But the Pluto dome is small enough that it can still roll on the railroad car wheels. And one of my favorite features of the telescope dome is this right here. Yes, that is in fact a boxing glove. There is a metal bar that conveniently sticks out of the telescope, and astronomers got tired of coming up here every night and whacking their head on it. So somewhere along the line, someone put a boxing glove on the end of the metal bar so it would cushion it at least a little bit. And the floor was once level with that concrete block you see holding up the telescope. It's not all of our astronomers are Shaquille O'Neal, which I guess the scale is kind of hard to see on video, but that bar is pretty up there now. So that is about all for our tour of the of the Pluto Discovery Telescope. I'll stop and see if anybody has any questions, but so the Clark telescope was changed to tire wheels because they work a lot better. And the Clark telescope dome is much more massive than the Pluto Discovery Telescope dome, and so it didn't quite roll as nicely on these railroad car wheels. That was an excellent question from Hope about why we changed the Clark telescope dome to car tires instead of keeping it as railroad car wheels like this one. So we are going to head on down to our Giovale Open Deck Observatory, which is not too far. So we've got another question. What is the telescope dome and telescope used for nowadays? The answer is it's a historical artifact now. So we don't typically use the Pluto Discovery Telescope for anything nowadays, but it was used up until the early 90s for things like proper motion surveys. So studying how stars do actually move in very, very tiny amounts throughout the sky. We've got another question. What is my favorite part of the Pluto telescope? And my favorite part would have to be, I think the whole thing. It's just a really incredible artifact. And I think it's incredible that we're able to share it with people. That's my favorite part. So now we are entering through the back of the Giovale Open Deck Observatory. This is our Astro Lab. As soon as I get my key out, we'll the Astro Lab. This is our Astro Lab. It houses a few exhibits. So now we are in the more modern part of Lowell Observatory. This is our newest telescope facility up here, and it's used entirely for public education. So you've got different exhibits about the sun and the moon and all kinds of different things around the building, as well as a fleet of fixed telescopes. So here they are. These are the 6 telescopes of the Giovale Open Deck Observatory. We'll start with the smallest one, all the way over here in the corner. It may be the smallest telescope of the Godo, as we call it, but it is by far a favorite among educators because it has incredible optics. This telescope we often refer to as the Tech because of its maker. It is a 5.5-inch telescope, so it's great for very wide field objects, or objects that take up a large portion of the sky. It also has incredibly clear optics, so the views we get through the telescope are crisp and clear. As I mentioned, it's a favorite among educators. Our next telescope, going up in size a little bit, is our 8-inch Moonraker refractor. So both of these telescopes here are refractors, meaning they use lenses to bend the light, and that light then focuses down to a single point. This is the same style as the Pluto telescope, though these typically have less lenses than the Pluto telescope does, which that one has 3. I know at least the Moonraker has 2. I forget how many the Tech has. But this is often quoted as our centerpiece of the Godo because it is such a beautiful telescope. It was created as a homage to our historic Clark refractor, and it is similar in the sense that it gets beautiful views of the planets and other objects like star clusters. It was created in this Victorian style, as I mentioned, as a homage to the Clark telescope. And it is an 8-inch refractor, so you can see that this aperture is a little bit bigger. All the telescopes are in storage right now because we're not using them during the day, so that's why they have lens covers on them. So you've got another question about what an example of a wide field object is that would take up large portions of the sky. And the moon is actually a really good example of that because the moon is pretty large compared to most telescope field of views. Like I mentioned, it takes up about half a degree in the night sky, which is fairly large compared to a lot of other objects, which will take up arc minutes. So that little white telescope back there is the telescope to use to look at the moon, in my opinion. Our next telescope is this 16-inch Meade-Schmidt-Cassegrain. So a Schmidt-Cassegrain telescope uses lenses and mirrors. So this one has a corrector plate in the front, which corrects for the fact that the mirror is not a paraboloid in shape, where it follows the curve of a parabola, but instead it's spherical. So it's a tiny portion of a sphere. The advantages of spherical mirrors are that they're a lot easier to manufacture, but they're not quite as accurate and you can't get them to focus quite as nicely. So we instead install a corrector plate at the front of the telescope that corrects for that misalignment. But this is a great all-purpose telescope. It's good at looking at a lot of mid-range objects, so things that are not terribly tiny and are not terribly large. This one does have the potential to have very small field of view, so we can use it to look at very small things in a lot of detail as well. Depends on what eyepiece you put in the end of it. So all of these telescopes that I've shown you so far, and the next one as well, these are all our optical telescopes that we use with our eyes. So we look through them through eyepieces. We'll get to the photographic telescopes in a little bit. But our next telescope is the 32-inch Star Structure Telescope. It has a 32-inch diameter mirror, making it one of the largest telescopes available for public use in the United States. It gives incredible views of deep sky objects. Because it has such a large light collecting area, it's really good at looking at dim things. So the bigger your telescope is, the more light your bucket can collect, essentially, if you think of the mirror like a light bucket. And the bigger that bucket is, the more light you can collect, and the better you can see dim objects. So this one is great at looking at things like galaxies. This time of year, we've got M81 and 82 up. They look phenomenal through this telescope. But it's also good at looking at things like the Orion Nebula, which is brighter and you can actually see with the unaided human eye. It gives incredible views of that as well. You can see little tiny stars dotted throughout the Orion Nebula. It's really something to see. I would highly recommend it. So we've got another question about how many telescopes we have at Lowell Observatory. For our public program, we have 8 telescopes that we use for viewing, plus the Pluto Discovery Telescope. And then we have several more that we use for research as well. So you can see other videos on our YouTube channel of taking tours of things like the Lowell Discovery Telescope, which is our largest telescope available for research. We have several other telescopes on sites like our Anderson Mesa site as well. So those are other telescopes. As for an exact number, I actually don't know off the top of my head, but we do have quite a few. We've collected them over the years. The observatory has been here for 120 some odd years, so we've collected lots and lots of telescopes along the way. There are even lots of telescopes on our Mars Hill site that aren't being used anymore, but are still there. So our last two telescopes for the Giovale Open Deck Observatory are these two. These are our photographic telescopes. They're both plane wave telescopes, which is the brand that makes them. This one over here is a 17-inch and the other one is a 14-inch. So one of them is just slightly smaller than the other. We use these two for imaging mostly. We are working on setting up the 17-inch to do imaging as well, but we primarily use the 14-inch for things like our premium access programs, where we would send you off with pictures of the night sky that we took for you. So that's primarily what we use these telescopes for. The 17-inch does have something called a spectrograph on the end of it, which is used to split up light into all of its component colors. And from there, we can see different absorption lines. These come from the very atoms that make something up, absorbing or emitting light. The absorption lines come from absorbing light, as you can imagine. But atoms only like to absorb certain colors of light, and so we can tell what something's made of by looking at its spectrum. And that's something that we can do with our 17-inch telescope, because it's outfitted with a spectrograph. So that is the telescopes of the Giovale Open Deck Observatory. See if I can get them all in there for you. Tech is hiding. But that is our Giovale Open Deck Observatory. As I mentioned before, it is where we do our premium access programs, or some of our premium access programs, which you can learn more about by visiting lowell.edu. We love getting to share these telescopes with people. It's one of the best parts of the job, is getting to share the night sky with other people, and of course historical artifacts like our Pluto Discovery Telescope as well. So I'll wait to see if there are any more questions. But while I do wait, I do want to mention that Lowell Observatory does several other live streams. We have 2 regular live streams that we do throughout the week. On Tuesdays at 8 p.m., we do interactive stargazing, which actually uses this 14-inch plane wave telescope. And we share with you views of the night sky, weather permitting, of course. We also have Cosmic Coffee on Thursday mornings at 9 a.m. So you can start your Thursdays off with a little bit of Lowell Observatory. And those bring you different topics in astronomy and the history of Lowell Observatory every week. So thank you all for tuning in. So you've got a great question about how this room opens up. So the white wall kind of towards the back behind the Moonraker, that red telescope, is actually a big garage door that opens up, and then the whole building, this whole part of the building that I'm in right now, slides back on a set of rails. So the building itself moves, the telescopes don't move. The telescopes are all fixed in place. That was a great question. Yeah, so I think I'll head back outside and I'll give you a tour of the outside of the Giovale Open Deck Observatory, because there are some neat exhibits outside as well. So you've got another question about our Dobsonian telescope, which is the 32-inch star structure. And that one does actually track, though it's not quite as accurate as our other telescopes. It does track all these telescopes are tracking. None of them are manual operated. So we actually have a set of iPads that we use to operate these telescopes. This is our donor wall back here. So all these lovely people donated money to help us get the Giovale Open Deck Observatory started in the first place. So thank you to everyone who donated. Along the rails over here, we have different quotes and equations that deal with astronomy and planetary science. We also have these plinths that show where the sun rises and sets on the summer solstice, the equinox, and the winter solstice. So this would show where the sun rises on the summer solstice here in Flagstaff. And then as we go along, we can see where the sun rises on the equinox. So both the equinoxes, the sun will rise and set in the same place. And then all the way over here, this shows where the sun will rise on the winter solstice. And similarly, we have plinths on the other side of the building that show where the sun sets on each of the important days. So we've got a number of things. In more normal times, when we would have open visitation and public access, we would allow people to peruse these exhibits and look at things like, where's the Milky Way located? Like this exhibit over here during the daytime when we're not using these telescopes. We've got another question about how many people work at Lowell Observatory. Again, I don't know the number off the top of my head. Currently, we have about 11 educators total. That's my department, where we do things like public education. We also have a number of astronomers as well, and associated research staff, so other people who do research. I don't know an exact number for how many people work at Lowell Observatory, but we have other positions as well, like we have our entire marketing team who does things like running these streams. So big thank you to people like Danielle, who is behind the scenes today, making sure the stream runs smoothly. If you have any other questions, feel free to put them in the YouTube chat and I will try and get to them. It's a beautiful day here in Flagstaff. We've got a number of other telescope domes you can see here. In fact, that white one that you see just to the right of the GODO was actually used to help map the moon during the Apollo missions, or the telescope that was inside there was used to do that. We've also got the Jiffy Pup, or the Lamplin Dome, through the trees there. You can see why we call it the Jiffy Pop Dome. It's silver and shiny, looks a lot like Jiffy Pop popcorn. But that one has been there for quite some time as well. We've got another question about our interactive stargazing, and that's, do we take requests? We do take requests. We can't honor all of them because sometimes people will request things that are below the horizon or really, really dim. But we do try and get to as many requests as we can throughout those live streams. I just want to thank everybody for tuning in today. It's been an honor to show you guys the Pluto Discovery Telescope and our Giovale Open Deck Observatory, and I hope that someday soon you will be able to visit us. Thank you all, and have a wonderful rest of your afternoon.